Over the next few videos, we're going to be talking about statistics. In this course, we're only doing an introduction to statistics. Statistics is a very big branch of mathematics that allows us to make a good decision based on numbers, on evidence. This is a great quote by Mark Twain. It says, "There are lies, damn lies, and statistics, because if we can, numbers will tell a story. So it depends on us if we understand the story and if we see the numbers for what they are, or other people are telling us lies with those same numbers." Statistics is the science of collecting, organizing, presenting, analyzing, and interpreting data to assist in making more effective decisions. As I told you before, we are using numbers as evidence and giving them a statistical analysis so we can make better decisions by manipulating, summarizing, and investigating data. Why do we study statistics? Data is everywhere. You can see it like all the time. Like we can see it in our phones for how many steps we do. We can see it on our smartwatches. You can see it again on your phones on how many apps you use and how much time you use it. You can see it in sports. You can see it in grades. You can see it everywhere. Statistical techniques are used to make many decisions that affect our lives. For example, if we are talking about your English grades, they will make the decision for you as to what group you're going to be into. If we're talking about medical insurance, numbers and statistics will tell you how much you got to pay, etc. No matter your career, you will make decisions that involve data. So understanding statistical methods will help you make these decisions effectively. There are two types of statistics. In this course, we're doing descriptive statistics, which is the methods of organizing, summarizing, and presenting data in an informative way. In other mathematical courses, you're going to be doing inferential statistics, which are the methods used to determine something about a population on the basis of a sample. This is an important word, population and sample. We are doing vocabulary here. Population is the entire set of individuals or objects of interest, and the measurements obtained from all individuals or objects of interest. And a sample is a part of the population. The population doesn't refer all the time to people. It refers to something that has the variable of interest. For example, if we were talking about shoe size, if you wanted to sell shoes. So if we wanted to sell shoes, we can either focus on females, or we could focus on males, or we could focus on high heels, or we could focus on sneakers. So depending on what you want to study, it's going to be your population. If we were talking about sneakers, our population is everybody that wears sneakers. It doesn't matter their age, or it doesn't matter their gender. It's everybody that wears sneakers. So a sample would be people in ad tech, for example, that wear sneakers. So here is all people that wear sneakers. This would be your population, and people at tech that wear sneakers is going to be your sample. So here's just an image about what I was saying. So in this case, our variable of interest is cars. So you can see all the cars, white cars, gray cars, black cars, and our sample are just some of them that are selected. Inferential statistics is very important because it is the process of drawing conclusions or making decisions on a population based on a sample results. Most of the time, going over all the population is very expensive and it is very time consuming. So we're doing our best to make a decision based on a good sample. Estimation is another thing that is done by inferential statistic. You're estimating, for example, the population weight using the sample mean weight. Or we can also do hypothesis testing, which is a big part of inferential statistics, which we have different tests that allows us to make a claim. So we're saying, for example, everybody in Mexico weighs 70 kilograms. That doesn't mean we weighted everybody in Mexico, but we took a good samples of male, females, children, teenagers, adults, older adults, and their mean weight was 70 kilograms. Descriptive statistics, on the other hand, is interested in collecting data, for example, through surveys or databases, and presenting data in tables and graphs, and summarizing data. In this case, in summarizing data, what we're going to be going over is central tendency. And we're also going over dispersion. So in this way, we want to summarize all of this data that we have collected and presenting it so we can make better sense of it, and summarizing it so we can actually make decisions based on them. Statistical data, which is a very important part of statistics, of course, is how we collect the information that we want to have. As I told you before, it is very relevant to the problem being studied, but it is difficult, expensive, and time-consuming to do the whole thing using a population. That's why we usually use samples. Statistical data is usually obtained by counting or measuring, and we could have primary data or secondary data. Primary data is data that is collected specifically for the analysis desired. So for example, if we measure everybody's height because we want to see the average of a group's height, that will be primary data. Secondary data has already been compiled and is available for statistical analysis. So maybe there's a database for teenagers' height, Mexican teenagers' height. And we can use that, and we can see, for example, we can just choose 17 and 18 years old height, and we can use that information. A variable is an item of interest that can take on many numerical values, and a constant is a fixed numerical value. Data can be qualitative or quantitative. Qualitative data is measurements that each fall into one of several categories. For example, hair color, ethnic groups, and other attributes of the population. Quantitative data is observations that are measured on a numerical scale. So you can see the difference. Quantitative data is important because we can do a lot of mathematics with it, while qualitative is more limited. Qualitative data is usually described in words or letters. It is not used as widely as quantitative data because it usually doesn't make sense to find the average or medians or standard deviations for hair color or blood type. Hair color is qualitative data, blood type is qualitative data. Also, names, smells, colors, how you're feeling, what is your perception, are all examples of qualitative data. Quantitative data is the result of counting or measuring. We can have two subgroups. We can either have discrete data, which is the result of counting. If it results in counting, that means we can only have integers. So we can have decimals anywhere because we're counting them. For example, accidents, number of children, pages in a book, we can have integers. If it is continuous, it is a result of measuring. And here we can have all numbers. So for example, temperature could be a continuous variables, money can be continuous variables, weight can be a continuous variable. When we are talking about quantitative data, we can have different scales of measurement. The first one is the nominal scale of measurement. It consists of categories in each of which the number of observations is recorded. The categories are in no logical order and have no particular relationship. They are mutually exclusive since an individual object or measurement can be included in only one of them. Nominal is just like the word says, these are names or descriptions. So for example, what could be a number name? The numbers that we have on our jerseys. So an athletic team, you can have players with a 10, a 7, a 23, a 44, a 52, a 71. These numbers are just names. They don't mean anything. They're not units of measurement. So that could be an example. An ordinal variable contains more information. It is order. A very good example here are the Olympics. So first, second, and third place do mean order, but it doesn't necessarily mean that between the 1 and the 2 we have one unit, or between the 2 and the 3 we have another unit, right? We could have a first and a second place that are very close, and then 10 minutes later we could have had a third place. So although it has more information, the values between them are not the same. Then we have interval and ratio. An interval variable is all the numerical measurements. The distance is of a known constant side. For example, temperature. So in 1 degrees or 2 degrees, the amount of heat here is the same. So we have the same heat. And between 2 and 3 degrees, we have the same amount of heat. But in this case, in an interval variable, the 0 doesn't make sense. So the 0 doesn't mean absence. The 0 is just arbitrary. On the other hand, on a ratio variable, it is numerical measures. The distance is a known constant side, and there is a 0 point. So for example, in money is a ratio variable because 0 does mean no money, right? So what other thing could be weight? So for example, if we have 0 kilos of apples, it means no apples. So that's the difference between interval and ratio variables. Here is a summary of what we can do with different types of variables. For example, for a nominal variable, we can count how many people are named John, for example. We can find the mode, right? How many Johns do we have in a room? The ordinal, it's order, of course. We can count how many they are. We can calculate a mode, and we can calculate a median because we can see how many firsts, seconds, and thirds, and fourths, and fifths we have, and that makes sense. Interval and ratio variables, if you see, we can do a lot of math with it. So the only difference between the interval and the ratio variables, we can have multiple and divide values, and we have a true 0. So here we cannot do that, but on the ratio variable, we can multiply and divide the values, and we have a true 0.